Now that you know a little bit more about expressions, let's see them in action. This code example starts with the declaration of an integer or int variable called x, which behaves exactly as you've already seen. Next, we initialize x to 4 plus 3 times 2. As you know from math, times has higher precedence than plus. So this expression evaluates to 4 plus 6, which is 10. So we put 10 in the box for x. Next, we declare another variable y of type int and initialize it to x minus 6, which is 10 minus 6, which is 4. So we create a box for y and put 4 in it. The last statement says x gets x times y. Sometimes novice programmers expect statements which look like this to behave like algebraic equations with an equal sign, where you might solve for x. However, that's not what happens. Instead, you follow the rules you've already learned. The right-hand side evaluates to 10 times 4, which is 40. And you put 40 in the box for x. Now, let's see another example. Before we work through this, take a moment to pause the video and see if you can figure out what values x, y, and z have at the end of this code fragment. Okay, let's step through it. First, we declare an initialized x. Next, we evaluate x times 3, which is 6, and initialize y to that value. Next, we compute y divided by 2, which is 3, and initialize z to that value. The last statement says x gets 2 plus z mod 2. Since the 2 plus z is in parentheses, we compute that first and get 5. Next, we compute 5 mod 2. Remember from your reading that 5 mod 2 means we divide 5 by 2, but take the remainder, not the quotient. So this expression evaluates to 1. So we update the value in x's box to be 1. Okay, great. Now you should be able to evaluate code involving a wide variety of mathematical expressions.